So yes, my project is on credit card fraud detection using machine learning. And so essentially, fraudulent transactions are being more common in the modern day, and they're easier and faster to perform over time. And this leads to misconduct in business front ends and even in personal life. So my solution to that was creating a model using machine learning to detect fraudulent transactions in real time and prevent the fraudulent credit activity. And this in turn would obviously help mark credit card fraud and boost the user's trust. So the data source I used was from a Kaggle dataset from that user, and it contains many fraud cases and legitimate cases. And the data science methodology was the CRISP DM process, where we understood the business problem first, and then we prepared the data. After that, we made a model based off XGBoost modeling, and then training the model and evaluating and deploying it in a cloud-ready platform in Streamlit. We use Python to do this, and within that we use XGBoost obviously and sklearn. So just a quick EDA. So the data we found in the data set had many features that showed importance and correlation, which we marked with XGBoost. So there are many important features like ratio to median purchase price, which was the highest correlation, and many others like distance from home, distance to transaction, and binary type ones like use chip and use PIN number. So the XGBoost and the correlation map matrix basically says that the ratio to median purchase price was the highest and the closest correlated with fraudulent transactions. Um, Unfortunately, in the data set, there was high imbalance at first. So that would have skewed our data quite badly. And in our first training process, that is what happened. But later on, we managed this imbalance by undersampling the legitimate cases to only 2 times the fraud cases. And after that, we gave it more balanced sets to train. And the sweet spot basically was in 2 times of legitimate data. And the overall training time was also significantly reduced. In our first initial training time, it took 2 hours, then 38 minutes, then 1 second, which is incredibly good. The data was stratified 80 to 20 and was randomized to ensure it was accurate and the fraud ratio is always consistent. So the model development was done by a classified XGBoost model and just random seed for reproducibility. The training was based on a correlation map, and the persistence was serialized. First, we did it in Google Colab Notebook and then moved it to a Git repo. Our evaluation matrix were in batch prediction, and key metrics were from F1 score and ROC AUC scores. So our scores were really good, and the F1 score was 99.72%, which is incredibly good, which indicates that our model converges very quickly, which is why we could undersample the data without sacrificing accuracy. And our accuracy, precision, and recall were also above 99.5%, with most of our true legitimate being marked and the fraud being also marked with very minimal false positives and false negatives. And the Streamlit I made was just a simple Streamlit to show it. Would you like me to present the Streamlit?
Yes, I'd like you to demonstrate your project also.
Yes. So this was my final project that I made in Streamlit. So this is a simple transaction showing, and this is just a gauge to show. So in the features, we can tweak the features and respectively say, like, if I had the ratio was 6 comparatively, then it'll update and be like, yes, this is a very highly fraudulent probability. And also just for higher business purposes, you could use batch processing, where you can have, suppose, an Excel sheet if it decides to load, just an Excel sheet of many data I believe in our initial data there was a billion training data, which is a lot. So it is very efficient with it. We can simply download this and upload it to the Streamlit, and then it should, yes, and then there it is. The final data, it shows that we only had one fraudulent data in our Excel, and there were many that were not marked. And it gives a fraud probability. It is very efficient in doing that, and this was the one that it marked as fraud. So that was the final project that I made in Streamlit.
Yeah, I think this project is really good and the accuracy is really high. So, what were the major challenges in the project that you faced?
The major challenges were handling the imbalance. As I said, at first, the imbalance was incredibly high with the data we had. As you can see, this was the Excel we had was copy pasted straight from it just for demonstration purposes. But there were very minimal fraudulent in the actual data set, and no other data set actually supported it. So we had to tweak it. But in our initial testing, I also saw that the model converged very quickly. So based off that, I can cut off the training data incredibly fast. And in turn, it also brought down the total training time from an hour to 38 minutes to a second, which is incredibly fast for XGBoost.
I see. I mean, it's really, how did you overcome this challenge? Can you go through it again?
So yes, in the collab, this is not the collab. I have three separate collabs which showed in our second collab, the model convergence was incredibly fast. So
Hmm.
I just cut off the data there. So it took a lot of repeated testing and just seeing that the model was converging. So just incredibly, the long data set was just the problem. Basically, that was the problem.
Okay. So, do you have any future plans for this project? Do you want to take it somewhere?
Probably, I mean, this is just credit card. Maybe combining it with some other data sets, you could extend it to maybe debit card or maybe even Gmail, email fraudulent email scanning, maybe something like that.
I see. Yeah. So, how were your teammates? Like, what were their contribution? What was your role?
Our this was an individual project because mainly I did the work in that. Our team never, like in the Google, every day we met, apart from I was only the one that actually joined in the classes.
Okay, I
We
see.
we were split
So,
into groups of three, that's why.
okay, okay. So, how are your experience with the mentors and the instructors?
Oh, very positive. The actually my mentor was the one who gave me the idea to just cut off the data,
Hmm.
since the training time was really good. So incredibly helpful.
Okay. So, are you deciding to participate in some hackathons? How are you planning to use this skill in the future?
I aim, well, in out of school, obviously, I am planning to go on to do some interns probably in the future, and obviously pursuing computer science. And apart from that, I would also like to use this in applied mathematics, where in sieving methods and in other classification type problems, they're incredibly helpful in mathematics.
I see. So, do you have any feedback for us? Like, how can we improve? Or you think there was something missing that we can add?
Um, Honestly, there wasn't much I could say that was missing from it. Just maybe uh, in the overall meetings that we had every Monday, Wednesday, and Friday, maybe just something more interactive, because just asking questions to everybody is not exactly the most helpful thing. So maybe something like group polling, just to keep everybody interacted constantly, that would probably help.
Okay, I think we can work on that. So, do you think the curriculum was at par? I mean, it was decent, or it met your expectations?
Yes, well, I'm comparing this with a previous one I've done. I've been at two other hackathons and also a Harvard program. And the quality of material, obviously, from there you will expect is very good. And this surprisingly also met the standards of that, which was incredibly surprising. Like, especially the NLP and RNN part, that was incredibly helpful. And the way we learned framing, that was incredibly on par with what I would have expected from a even better or top university type program.
That's really good to hear. So, do you have any parents around?
My parents are downstairs. Would you like me to call them?
Yeah, sure.
Okay, give